antingen så får du tala högt och tydligt, eller också så har vi... Är vi på gång?
Ja, jag tror det. Ja.
Ja, just det. Stänger vi ner allting här. Have you tried rebooting it? Okej. Det är uppenbarligen så att den här styrsystemet har ett hidden gun mode. Du måste trycka. Speciellt knapp kommer.
Jag kör gärna utan mikrofon, men de funkar.
Ja, men jag tror att de där uppe vill ha med mick. Det blir inte MTV-unplugged. Så. Nu ser du så.
Ja vel. Anders var så vennlig å invitere meg hit for å snakke litt norsk, og jeg vet ikke om vi har så mye mer å tilby enn dere har fra før, men jeg skal nå vise dere litt hva vi gjør i Norge når det gjelder trådløs generelt, men spesielt EduRoam. Litt om andre prosjekter vi har på gang, egentlig bare ett. Men så fikk jeg da en beskjed fra min sjef når jeg skulle hit at jeg kunne ikke dra hit uten å si noe om Uninett generelt. Så jeg tar noen ord om Uninett først. Det er ikke det jeg er best på. Selv etter 1,5 år så har vi ikke fått alt inn i systemet, har jeg nær sagt. Så godt kan jeg ikke den delen. Så spørsmålet får dere ta når vi kommer til EduRoam og det trådløse. Jeg kan jo si 2 år om meg selv først, da, som nå har jeg vært som sagt snart 1,5 år i Uninett. Før det så var jeg bortimot 16 år i Netcom, telekom-operatør, eller det vil si det er vel egentlig Telia Sonera Norge, heter de siste 2 åra. Da jobbet jeg i siste 10 år i hvert fall på core og IP-drift der, og hadde en sånn gruppelederjobb de siste 2 åra. Så routing og switching har jeg vært mye borti tidligere, men lite på wifi og den biten der som jeg nå driver med. Men jeg synes det var spennende å få lov til å jobbe med noe teknisk igjen. Så litt om Uninett. Vi holder til i Trondheim. Det er heleid av Kunnskapsdepartementet, og vi er nå, jeg tror vi er oppe i 110 ansatte. Og hovedoppgaven er jo, som for så vidt er i Sverige sikkert, det er altså drift av det nasjonale forskningsnettet, og en tilhørende tjenester. Det er vel en slide til på litt mer av det senere. Vi er også med i forskjellige internasjonalt samarbeid. Jeg nevner 2 ting her fordi at det har med trådløse å gjøre. Det er innen SHAN så er vi med i en gruppe som lager sånne campus best practices, som dere vet er offentlig tilgjengelig også for alle. Og vi har jo noen der på trådløs, men det er også innen mange andre områder for så vidt. Og så er vi med i Terena i TF Mobility, og det er vel der jeg traff Anders. De har møter, jeg har kanskje vært på 3-4 stykk. Og ser på kommende, får jeg si, det man forventer kommer innen mobility da. Ja. 3 kjerneverdier, samfunnsansvar, åpenhet og teknologientusiasme. Det er jo det siste her som særlig vi ingeniører brenner for, selv om de 2 andre er like viktige. Her er det litt mer om de tjenestene som Uninett leverer. Uninett er et morselskap som heter Uninett, og så er det 2 datterselskap, Sigma og Norid. Og Sigma står for jobber inn mot forskningsmiljø og tungregne maskiner, for å si, mens Norid administrerer .no-domenet. Og i Uninett-selskapet selv så er det jo ca. 200 institusjoner som er medlemmer, og rundt 300 000 brukere. Selve forskningsnettet består i hovedsak av høykapasitetslinjer 1, 10 og 100 gig. Vi har 100 gig i drift mellom Trondheim og Oslo, og så er man i ferd med å skifte ut de andre linkene fra 1 til 10 gig. Så i løpet av det året her så er man med over på 10 gig overalt på de største forbindelsene. Utstyret som vi har i kjernenettet er Juniper og Cisco i hovedsak, så vidt litt HP, mens ute på campus så er det Cisco og HP. Så kommer vi litt mer over på trådløs-biten. Udinet har per nå innkjøpsavtale med 3 leverandører. Det er Datametrix, Intelecom og IPNet, som forhandler henholdsvis Cisco, Aruba og Trapez, eller Juniper. De aller fleste institusjoner i Norge kjører Cisco. Det er noen som, altså en 4, 5, muligens 6 nå, som er på vei eller har migrert til Aruba. Alle de som har flyttet til Aruba rapporterer at de er veldig fornøyd. De synes det fungerer smertefritt for så vidt. Og de har jo gått fra Cisco til Aruba og synes det er bra, og andre igjen gjør alt de kan for å beholde Cisco og synes det er best, så der er det nok delte meninger. Det er enda en del små institusjoner som kun kjører også autonome AP-er. Så Anders gjorde en sjekk her i dag på hva de forskjellige hadde. I Norge så er det ganske jevn fordeling på radius som man bruker mot Ederom, på FreeRadius og NPS, eller Windows-basert. Cisco-løsninger finnes og der. Så ligger vi litt etter da. Vi så jo på antall lokasjoner her i Sverige og antall aksesspunkter. I Norge så har vi nå, det som er registrert på Ederom.no er i overkant av 300 lokasjoner, fordelt på de 40 deltagende institusjonene. Vi har litt jobb der å gjøre for å få opp Ederom.no-siden vår til å være like oppdatert som deres. Den er i dag basert på det som finnes i en lokal driftsdatabase hos Udinet, og det er Udinet som oppdaterer den etter innspill fra institusjonene. Og den, for halvannet år siden, så var det 18 lokasjoner, og nå har vi kommet opp til 300 da. Men vi har enda en del å gå på der. Og sånne tilfeller som, vi har noen sånne serviceprovidere som gir at, blant annet i Trondheim, så har vi Trådløs i Trondheim, og de er ikke med på det kartet her, men via dem så har vi jo dekning i stort sett hele Trondheim sentrum. Og det er jo, jeg sier litt mer om det senere, men det er jo noe vi håper å få utvidet og få rullet ut Ederom mer via da. Det er jo som her Udinet som drifter toppnivå-radiusene, som er Radseg-proxy-basert. Vi har jo der enablet IPv6 og gjort klar til dynamisk routing av radiusrequester, men det betyr jo ikke at det er i bruk, for når ingen andre har satt opp, så sånn er situasjonen per i dag. Tilsvarende som dere har her, så har vi Ederom.no websiden, der det står en del informasjon, og det er også linker da videre til noen verktøy som jeg straks kommer inn på. Vi fikk på plass et verktøy i fjor, og slutten av fjoråret, som vi har kalt for Realm Check, som viser litt av statusen på de forskjellige realmene rundt omkring. Så det er en kolonne for konnektivitetssjekk. Der kjører vi her IP-test-programmet som kommer med VPA-supplikanten. Den kjøres en gang i døgnet mot de forskjellige realmene, og så setter vi en status inn her etter det. Jeg tenkte vi skulle gå og se på den siden etterpå. Og så gjøres det da de 3 neste kolonnene som heter for Loop og IDP Service Provider status, det bygd på radiuslogger fra døgnet før. Den siden her oppdateres altså hver natt. Og da ser vi jo på, vi ser på alle radiusrekordene for hver TL. Finnes det noen loop her, så blir det indikert her. Finnes det, IDP-stasen OK, det vil si, ser vi access requests, og hvis vi gjør det, så det for så vidt pass, men hvis det da forholdet mellom rejects og accepts blir, jeg tror det under 0,3, så flagger vi at her potensielt et problem da. Jeg tenkte kanskje jeg skulle klare å vise fram det her. Vi ser sånn. Ja, nå ser man jo her at dette her langt fra perfekt på connectivity-sjekken, så når det står OK her, så hvis man legger cursoren over, så får man opp en forklaring. Her sier den jo at for de som får OK, de fleste av de i hvert fall, så det årsaken at det ikke har foregått noe IP-konversasjon. Vi kjører jo en test med bare en testbruker som ikke finnes. Og jeg har vel en mistanke om at de fleste som feiler her Windows-baserte radioservere som rejecter før han gjør noen IP-dialog. Men det kan for så vidt være andre årsaker. Dette her da ment som et verktøy for de forskjellige institusjonene, at de kan gå inn her, og når det flagger gult eller rødt, at de må gå inn og gjøre en sjekk og finne ut hvorfor det skjer da. Tilsvarende når det da flagget en loop her, så har jo vi sett rekord som kommer fra institusjon som vi sender tilbake. Vi har jo den loop protection enablet, men noen har da 2 radioservere, og da kan vi se, da blir det indikert her. Når vi da flagger gult her, så ser vi at det et større antall rejects enn accepts på det realmet. Og da det gjerne klientoppsett som feil. Det har vi sett ofte, men det kan selvfølgelig også være andre årsaker. Når vi da flagger feil her, så det fordi at det ikke har gått noen trafikk. Vi ser ikke reject og ikke accepts. Det gjerne litt, ja, det kan skje helger for eksempel, og det skjer på mindre institusjoner der det lite trafikk. Jeg kan komme tilbake til det her, for her det altså, når vi flagger en feil, så det linket til det verktøyet som heter EduDebug, så man kan gå inn og se i bakgrunnen hva som årsaken til at den feilen her blir indikert da. Jeg kan komme tilbake til den, vi kan se på det her EduDebug verktøyet først. Det ser sånn ut. Det var noe som kom på plass rett før jeg startet i Uninett, der man rett og slett samler inn logger fra begge RadSec-proxyene, samler dem i en database, og så har man da utviklet et par programmer som tilgjengeliggjør dette her. Og interfacet ser sånn ut som dere ser her. Her kan man søke på forskjellige kriterier innen du angir dato, du angir brukernavn, du angir hvilke sånn i det tilfellet her så har jeg skrevet Uninett, og så kan man se på den dataen hva som har skjedd. Vi kan se det her når jeg ser. Det mer nyttig når man kommer fra EduDebug og man har et konkret problem å feilsøke på. Jeg nevnte vel så vidt at EduDebug består av 4 forskjellige komponenter. Det den loggeren som samler loggfilene, får det inn i databasen. Det selve webtjenesten som brukeren logger seg inn på. Og så er det 2 plugins, altså en authentication og en authorization, som brukeren som når han skal inn på debug, så må han logge seg inn her, og da får man da tilgang kun til trafikk som er relatert til eget realm. Enten det er noen som er ute og råner, eller noen som er på besøk hos den institusjonen. Så man ser ikke noe mer enn det du har gjort på sin egen radioserver. Ja, mer et grafisk bilde av grafisk bilde av hvordan det er bygd opp. Dataen hentes inn, og man logger inn og kan se og grensesnittet. Da, hvis jeg nå går tilbake til ja, eksempelvis så står det jo trykker på der er indikert en loop-situasjon. Og hvis de ser inn her nå, så ser jeg at det da har for det første så er klienten feiloppsatt, for han kommer inn med den type brukernavn. Og når det er blankt realm, så av en eller annen grunn, så sender de da den til, så går den via de nasjonale, og så klarer vi å tolke den type brukernavn som da går tilbake. Så dette her er rett og slett noe som er for så vidt lett å fikse, men krever jo at man tar i bruk verktøyet og Jeg kan jo se på en av disse her også. Her er det jo indikert med et gult lys på IDP-statusen, fordi at han har masse rejects og ikke accepts. Så jeg går inn der. Nå ser jeg at jeg ikke måtte gjøre noe autentisering, men det var fordi jeg har vært inne der tidligere. Så ja, hva har skjedd her? Det første er vel greit. Han blir rejectet antageligvis fordi han har feil passord. Men i og med at det er mange rejects her og jeg ikke ser alle, kan jeg gå inn her og velge se bare på ofte så er dette her feilkonfigurerte klienter som genererer sånne ting. Og gjerne samme brukeren opp igjen som forsøker å bare få rejects. Så det er for så vidt ikke, i det tilfellet, ikke en sånn stor feil. Det er mer en bruker som prøver veldig hardt å komme seg inn. Jeg vet ikke, det er bare å spørre, det ble forferdelig stille. Skal vi se, ja, nå må jeg få bort den der igjen. Sånn. Da tenkte jeg å si litt om det som er planene videre for Edurom i Norge. Nå nevnte Anders katt her tidligere i dag, så nå vet alle hva det er. Vi hadde jo en liten trådløssamling i Stockholm faktisk, i forbindelse med den workshopen som var. Og da hadde vi en norsk dag, og der reklamerte vi litt for katt, og det har gjort sin utslag. Vi har nå, i dag så har vi fått en til, så nå er det 18 av 40 da, som har tatt i bruk det kattullet. Og jeg tror at det kan hjelpe ganske mye på å få klienter for det første korrekt konfigurert, men også at de faktisk gjør sertifikatsjekk. Og så, som jeg sa tidligere, så har ikke vi nå Institusjonen oppdaterer ikke Edurom-databasen selv, det gjøres via vår driftsdatabase, og det er ingen optimal løsning. Så mitt forslag er at vi skal bruke en sånn gresk løsning, for å si det sånn. En greker har utviklet et grensesnitt for det her, som vi tenker å få lagt inn på Edurom.no, slik at hver enkelt kan få oppdatere sin database, og det betyr at vi kan legge litt mer press på å få gjort det da. Vi tenker også å utvide den realm-sjekken nå. Vi har fått et forslag om å legge inn en sjekk av at det går accounting, og vi har fått et par andre forslag som vi vurderer, men i hvert fall det blir en utvidelse på det. Vi håper å få flere som kjører radiusen sin på IPv6, og at vi får den trafikken over dit, så vi kan gå ut og si at vi gjør noe med IPv6 i hvert fall, på det området.
Uppmuntrar ni att man ska byta och köra radius på IPv6, eller har ni det som fallback? Eller?
Vi har det som, eller da håper vi å ha IPv4 som fallback da.
IPv4 som fallback?
Ja. Vi oppmuntrer å sette begge deler da. Det er vel bare foreløpig én institusjon som er ivrig på det, som gjerne vil, men vi håper at det kommer flere. Og så har vi tenkt å oppfordre fremover til at vi også skal begynne å gjøre dynamisk routing, i hvert fall på toppnivå da. Det vil altså si at institusjonen legger inn Napter records, slik at internasjonal trafikken går direkte. Men ikke da på nasjonalt nivå, for den nasjonale trafikken, det vil jo for så vidt, hvis man begynte å gjøre det der, så vil jo vi miste det edu-debug-verktøyet vårt, det ville ikke funke lenger da, med mindre vi da introduserte FTX, som det var snakk om her før i dag. Vi har per i dag, så gjøres ikke Edurom-autentisering mot feide, altså det er jo felles elektronisk identitetssystem, som er motsatsen til Svamid, hvis jeg skjønte dette. Og det vil nok lette, for det vil være en fordel å komme over på det, men samtidig så må vi tette de sikkerhetshøla som er med sertifikatsjekker sånn, før vi synes at det er ok å gå dit. Så har vi snakket med 2 operatører i Norge om LTE, testing av LTE og offload til Wi-Fi. Begge har i utgangspunktet stilt seg veldig positivt til det. Og det ble snakket litt om det i går også, fra han karen fra Aruba her. Og det har jeg tro på at det er noe som kommer. Men for så vidt også onload andre veien, og vi snakker om å kanskje ha et eget Edurom APN hos en operatør. Og det vil jo kanskje gi da en mulighet til å ta også den 4G-trafikken rett inn i vårt nett igjen. Og sist, men ikke minst, så er vi jo veldig interessert i en utvidelse av The Cloud, som dere har fått til her i Sverige. Vi jobber litt med det nå om dagen, og håper i hvert fall å få flyplassene inn. Vi har vel ikke sett noen sånn tilsvarende aktør som Cloud i Norge. Cloud er ikke så store der. Det finnes jo andre som Telenor, men hva de ønsker, det vet vi ikke. Vi er i prat med Telenor om, men ikke akkurat om det der, så det kommer vel når vi har vært en runde med Avinor. Men videregående skole er for så vidt et tema vi har vært inne på, men da igjen, hvordan skal de henge på? Skal det være nærmeste høyskoleuniversitet som har ansvaret for et x antall videregående skoler? Det er spørsmål vi ikke har noe avklarte svar på. Så skal jeg bare nevne et sånt trådløsprosjekt til som vi jobber litt med. Det er en felles gjesteportal, altså det er flere det finnes mange forskjellige gjesteløsninger rundt omkring, og noen er fornøyd, og noen synes ikke det fungerer bra, og noen har bare en webnøkkel, og det er helt tatt mye forskjellig. Så vi har satt opp en test på det inne på Uninett nå, der vi bruker friradius og et modem rett og slett, og en captive portal. Man sender en SMS med et visst innhold, får brukernavn og passord tilbake, og kommer seg på den måten. Men dette her ser vi at vi kan få til å skalere og få det ut til hele sektoren. Og nå har jo da Aruba kom på banen og tilbudt sin ClearPass, som han snakket om i går. Så det det neste steget før vi tester det ut i sektoren, og så skal vi få på plass ClearPass. Det har vi for så vidt internt, men vi må få konfigurert og sett at den har all den funksjonaliteten som Aruba påstår at den har. Foreløpig så ser det lovende ut, og jeg tror nok at og Aruba veldig innstilt på at vi skal få dette her til en rimelig pris, for de vil selvfølgelig inn, og de ser nok det som en av mulighetene. Ja, her bare en skisse hvordan det her tenkt. Altså, vi kan jo ha x antall kontrollere, det 40 stykk som alle gjør autentisering mot den samme, da eventuelt ClearPass-plattformen hos oss. Og de kan jo gjerne ha forskjellige portals og ha sitt eget logo og så videre og så videre. Da hadde jeg for så vidt ikke tenkt å si så mye mer. Det et spørsmål, eller?
Ja, när körde ni igång med Edrom i Norge? Vilket år kom?
Det var vel...
Det fel person att fråga.
Nei, men de feiret vel 10-årsjubileum for Edrom i fjor. De hadde i hvert fall en markering, så da vil jeg anta det var 2002-2003 da, rundt der. Stemmer det? Det samme her, eller?
Ja, ni var några år före då, med andra ord. Andra frågor, funderingar? Eller var det vanskelig att följa med?
Det kan hende. Jeg tror ikke innholdet var så vanskelig, men jeg tror kanskje norsken var vanskelig.
Ja.
Jag har ett spörsmål. I centrala Trondheim fanns möjlighet att använda Edrom.
Ja, stemmer det.
Det bedrifterna tycker jag.
Ja, det der kaféer og utesteder, har jeg nær sagt. For Trollhus og Trondheim jo et sånt kommunalt tiltak som også da har fått spre Edrom, da. Men de jo da knyttet via NTNU, så det NTNU som tar seg av radius-requesten derfra.
Kan vi forvente at det blir samme i Oslo?
Nei, jeg har ingen klart svar på det. Jeg skulle ønske jeg kunne si ja til det, men nei. Men en eller annen leverandør kan vi kanskje se for oss. Altså, vi håper jo å få spredt det rundt mer.
Ja, då tackar vi. Tycker han har förtjänat en applåd. Han har åkt hela vägen.
Takk.
Tack så mycket. Då det väl dags för mig att packa ihop och sätta mig och försöka uppföra mig. Så lämnar vi över ordet till Börje.
Ja, men jag tycker vi tackar Anders för en bra genomförd genom dagen här på. Då ska vi göra en glidande övergång till träffpunkt. And I will change my language to English and present Jerry Sobieski from Nordernet, who works there with international research initiatives. And he's going to tell us a bit about something called NSI, Network Service Interface. Welcome.
Thank you. Good morning. So I've been working on this project called the Network Service Interface now for several years. This is it's an introduction. I'm going to give you a brief introduction to it. We've put about 3 years into it, and it is actually a collaborative effort by a number of organizations in the R&E community. And I think you'll see at the end of this that we have a lot of momentum, and this could be a major asset to us in the coming years. So what is NSI? This Network Service Interface, we've had a lot of projects over the last decade that have dealt with connection-oriented services. In particular, the development and testing of various control plane models for provisioning these services. Well, we understand how to do this fairly well now, but we haven't had an opportunity to really standardize it so that everybody can do it the same way. So that's where NSI came about. We took it to an organization called the Open Grid Forum to be the standards organization. It's kind of an interim step. At the time we started, this seemed like a good place where the community, the educational community, was doing a lot of kind of high-level grid-based standardization. So this was a good place to start. There are some other standards in there that are related to NSI. One called the network markup language, which is topology descriptions, and some other things about performance monitoring and such. So this is one of those standards. So I'm going to give you a little overview of what NSI is technically, and what we're doing to test it, and its evolution, how it's growing and being deployed, and a little bit about where we're going with it and why we think it's so important. The NSI is a framework. It talks about the network as an architecture rather than as simply a set of pipes and boxes and switches, right? So it has a model, it actually asserts a model of what it thinks the network should look like, and then a set of protocols that operate across that topological model. We have right now 3 protocols that we're standardizing in this round that will be documented here in the next few weeks, and you'll be able to actually get a document and read up on these. The first one is this connection service protocol. We've been working on this one the most diligently for the last 2.5 years. The discovery protocol and the topology protocol, I'll talk a little bit more about those later. Then we have some others that we see coming down the pipe over the next year or two that we're gonna need. So NSI features, it's a framework, right? So it just describes the environment that we want to be able to operate in. It's an inter-domain set of protocols. We're not trying to reinvent GMPLS or any of the other ITU control plane protocols. But we do think that we need some way of expressing these operational semantics across different domains so that we can express it across Nordinet, across Giant, across Internet 2, maybe into Asia, depending on where these circuits need to be set up to, right? We've taken a technology agnostic approach to it because we have multi-protocol networks today, at lots of different, different layers, different versions, different policies. We can't rely on one particular technology to be everywhere, right? Even the IP layer can cause problems. The service itself, we don't try to define what the service is. Other than the fact that we're trying to build these pipes. And so that's why it's very customizable. We can say, if you just want an Ethernet VLAN, we can construct a service that looks like that uses the same NSI primitives. If you want something that looks more like a TDM or a SONET-based circuit, or just a raw, spectral circuit like a fiber, we could define a service like that. So there's a lot of options here. Maybe I hope you'll see these as I get a little bit further into this. And one of the things that is really critical to all these protocols is their security. In the past, we've tended to be researchers and scientists in a very collaborative educational environment. And we've kind of put security and privacy and control of information kind of secondary. But if we really want these protocols to be deployed globally, we have to understand that this is no longer a secondary consideration. It has to be something that's integrated into these protocols from the outset. And so we've tried to do that. The basic architecture is you have your protocols, and they exist between 2 agents. We call these network service agents. Don't worry about the technical platform and such, but these are just agents that implement the protocols. A network service agent generally is responsible for a network, some sort of service domain across which it's going to provision these circuits. We identify things like the Network Resource Manager, which is an intra-domain tool or network management system or provisioning system. But we don't specify what that internal process is. Norgenet has their internal provisioning process. Xiang has their internal provisioning process. We don't want to get into that. We let each network do what they want. But we do specify this notion of the larger domain here that says we're going to put circuits across this domain. So how does this work? There's a set of NSI service domains. In this case, we just use these arbitrary names. And at the edge of these domains are service termination points. These are still abstract concepts. Don't worry about whether those are Ethernet or SONET ports or IP ports. But those termination points essentially define the boundary of the network. And we define the third aspect here is the adjacencies of these networks, where any of two of these ports are linked to one another. That's where data can transfer across these networks. This is what would be called in computer science a resource graph, because all your actual resources are inside these bubbles. There's nothing actually that extends in between them. These are simply relationships. That's probably more obvious in this next slide. So the connection, in NSI, we deal with connections. We don't deal with SONET circuits or LSPs or VLANs. We deal with connections. Hang on, wait for it, there we go. So we have these connections across these networks. And when we specify a request, we just give the network and the termination point for that connection, the start and the source and the destination. And if you start to see what's happening here, what you're going to see is that these service demarcation points are really where we just concatenate these segments of the end-to-end circuit. So there's a connection life cycle. Without going into a lot of detail, I'm just going to walk through kind of the basic process here. A user or a requesting agent will issue a reservation request. And the provider agent that processes that request will go out somehow, we don't get to it in a minute, and find resources and hold those resources for the request. Sometime later, and confirm it back to the user. Then sometime later, the user is going to have to come back and say, all right, yes, those resources you held for me a while ago, please commit those to a reservation and make sure it starts on time. The reason we do this two-phase commit is because the future says that we're going to have to coordinate these circuits with other non-transport resources. Either these are going to be provisioning cloud services or other types of processing capabilities, computational processes, storage processes. And so there's this path planning, this resource planning process that says, well, I'm going to ask for these resources. I'm going to go out and try to find other ones. Oh, I can't find those, so now I got to throw these out and get some different resources. So this will help us as we get into this multi-species types of provisioning services that we anticipate for virtualized services in the future. Having committed these processes, there's now a circuit been reserved across all the various domains that it needs to, and it's going to sit there. It's going to have a start time associated with it. When that start time arrives, that basically says now those resources can be put into service for the user. The user has to issue a provision request to say, yes, I'm ready for them, please put them into service. And the user can actually issue that request before the start time, but it won't actually happen until the start time. So that window of when you ask for a circuit to be scheduled, which can be on demand, right? We can say, just go ahead and schedule it for now. But the user still has to say, I want to provision it. The reason we did that was because it turned out over long periods of time, if these circuits are stood up for weeks or months or years, there's times when you want to take these circuits out of service without actually releasing the resources. You want to do maintenance or some other process. And so there's a release function that's kind of a complement to the provision function. And that way, we can have all the resources allocated. We can put them into service, and now everybody's going to set up alarms if something goes down. 2 months later, we need to take it out of service to do maintenance in one of the networks along the way. We can release it. All the networks can be notified. They can drop their alarms. They can do some stuff. Then we can put it back into service. Everybody will turn their alarms back on. So this was actually an operational thing that we decided we needed. And then ultimately, when the circuit is no longer required and the resources are no longer required, we can terminate the reservation and everything evaporates. Everything is released back to the available pool. This is what the requests look like. I'm not going to go into a lot of detail, but basically it's a recursive process, right? When I issue a reservation request to an agent, a provider agent, that provider agent is going to look at that request and possibly issue sub-requests to other networks along the path. And they can do likewise. And at the end of the day, this builds a service tree. I'll get to that in a moment. The basic commands here, the only thing I'm going to say here before because I've already kind of explained these, is the reservation actually serves two purposes. It serves to reserve the resources initially, and then later on, it serves to modify those resources. If we need more bandwidth or we need to extend the end time, we can issue a subsequent reservation request, this time using the reservation ID that was provided to us on the original request. And the provider agents down the line will know, oh, I need to modify the requirements, the resources associated with this circuit. There are two other primitives that I'll note here as well. One is the query. It has two forms in itself, which is, the first form is very basic. It tells us the status of a circuit. If I was the requesting agent, I got the circuit built and sitting there, now I want to come back and say, well, what is the status of it? Is it up, is it down, is it released, what have you? I can issue a query request. There's also a detailed query request that provides all the information that can be found about this circuit. Now, this request is a little bit more complex because, as you'll see in a moment, there's a lot of networks that have participated in serving, and actually building the circuit. And not all the information associated with those downstream networks is public information. It could be proprietary, it could be secured information. So this second detailed query actually has to be authorized very carefully. The notify primitive is actually just something that says, we had an error down here. We can toss an error message up the tree to let the agents know that something broke. So let's talk a little bit about pathfinding. NSI does not specify how these agents choose a path. That's up to each agent. When a provider agent gets a request, it has the full flexibility to decide how to solve that request, how to service it. There are some requirements. One is that the characteristics that come with the request, this much capacity has to transit these points along the network, those still have to be met. The provider agent, when he confirms that request, says, I confirm everything that you asked for, and here's the results. But everything that the user didn't specifically identify, if he says, just go through these networks, but then specify a path through there, then that provider agent has to choose that path himself, and he can use whatever process he likes. So, so this is a recursive process. What we call the ultimate requester starts this process as, I need a circuit between these two endpoints, one maybe in Japan, one maybe in Sweden. He sends that to a provider agent who looks at it and says, well, I can do part of this over Giant, part of this can go over internet too, part of this will go over the JGNX. That agent can then issue sub-requests to each of those networks. So, and you end up with this thing called a service tree, where each of these children's segments are just requests in and of themselves as well. So we're using the same protocol between all of these. But we do get down to some point where we have an agent, a network service agent, that doesn't, the request was everything is internal to that network. That agent just translates the request to whatever their local network management system or resource manager requires and issues that request. And then translates in your response into an NSI primitive semantics and passes it back up the tree as a confirmation or a rejection. So this service tree is very important, and this is a unique aspect of NSI. You've never had something like this in prior protocols. Now, so why is this important? Well, it provides the chain. We call it 2 ways of segmentation, this chain process where we can support the conventional process of hop by hop, path selection and provisioning. But it also gives us this new process whereby one agent can talk to each downstream network directly through this tree function, right? This is really useful because it allows each network to provide a direct relationship with the requesters that are using it. So if ESNet, for instance, which is the US Department of Energy, if they insist on knowing who uses their network, then they can insist on these agents to talk to them directly. And he won't honor any other request. So this tree function is really, really important. It's novel and it's going to be very useful. As it turns out, the chain function is just a degenerate case of the tree. If you just walk down one branch of a tree, it's the hop by hop chain function. So this is all actually quite elegant. One thing I will note is that when we talk about that tree function, here's some examples. We're not saying that these are done in parallel. All it means is that we are talking directly to each of those downstream networks. It's only in the provisioning stage when we've already reserved everything, we know our path is confirmed. We can't actually issue these provision requests in parallel, and we might be able to save some time there. But there are still dependencies in these, as we choose the path between these downstream segments, there's still path dependencies, so we still have to understand that we might have to crank back if we have a problem. So there's some interesting issues here, but this NSI allows us to do this traditional chain processing. If that's what we want to do, we can do a tree model. We can do things like third-party requests. In the past, ITU specs didn't typically support this. Even GMPLS pretty much assumed that you needed to go end-to-end, that the request started here and ended there. Now we have an ability that some third-party agent can say, I need a request from Switzerland to California. And it doesn't need to be at one end or the other. So NSI is technology agnostic. What do we mean by that? Well, we have all these networks. They have NSAs, these agents that are talking for them. And we're provisioning these generic pipes across these networks. But we don't consider these pipes to be LSPs or VLANs or SONET circuits or fiber. We don't have these fixed requirements like GMPLS does, or worse, like some of the other prior control planes that just assumed you had a certain technology, frame relay, ATM, or some such like that. But what we allow them to do is each network, we have these service specifications that define what we're providing as a service, but we let each particular network engineer them as they see fit. So one network, for instance, if we wanted to do something called you see an example, I think in here, called an Ethernet transport service, where the circuit looks like a VLAN. But we don't require any of these intervening transit networks to actually provision Ethernet VLANs. They could do Ethernet if they wish, But they could do Ethernet over MPLS. In fact, that's what Nordinet will probably do. That's our plan of record. They could do Ethernet over waves, SDH sonnet circuits or something, GFP encapsulation. They could even have an SDN network in the middle that transports the frames across their network. As long as they're presented as an Ethernet 802.11 or 802.1 frame, we don't really care how the network actually gets it transported across the network, across their internal infrastructure. Security and privacy. Since it's an interdomain protocol, every one of those primitives transits domains, right? Whenever we issue a reserve or provision or release, and so every one of those primitives is authorized by the provider agent that receives them. This is really important so that well, there's actually two levels of authorization here. The first is when two NSAs want to talk to one another. For instance, Nordinet may be willing to talk to any agent that's in the Nordic region, but we don't necessarily want to talk directly to agents in Asia Pacific region or in South America. We may rather prefer they talk to their local agents and they have relationships up and down, kind of in a hierarchical fashion. So you might see something like Nordinet willing to talk to Internet to Canary and Xi'an, but we expect folks in South America to talk to their regional provider, talk to Internet to, or talk to Xi'an and then to us, right? So this allows us to authenticate and authorize the NSAs and how they talk to one another. And this is also expressed in the topology so that we know where to send these requests. Once we've got two NSAs that are able to talk to one another, then they're going to send these reservation requests. Now we actually have to look at the credentials that they provided to say, who actually asked for this? We don't assume anything about where those credentials were found, but as a provider agent, I look at the credentials and say, yes, I know I'm talking to Xi'an. Now let's see who's asking for this. Oh, it's one of the high energy physicists. Okay, I know those guys. Well, I'll let that one through. So we actually have a lot of authorization and security in here. Plus, there's another aspect here. Some of this information that the provider uses when they construct a service, when they respond to a service request, some of that is proprietary information. Now, they may use a certain downstream network because it's cheaper or because they happen to have a better relationship with that. They know they have better service. They may not want to announce who they're using, right? So the request, even a detailed query request, even from the user that asks for the circuit, still has to be authorized. And some of this information is not the same authorization level that the user would be entitled to just because they got the circuit built. So, long story short, security and privacy is critical, and I think we've done a really good job, probably a better job than any other protocol has to this point. So where are we now? So that was a basic overview of NSI and how it's working. We have now, as of today, the Charlottesville suite. We were calling this version 1, and up to now we've called it version 2, but now we actually have multiple protocols, and they're not all the same version, right? So, for lack of a better term, we'll just call this the Charlottesville suite because it's where it was finalized. We had an OGF meeting in Charlottesville, Virginia last month. So, we are currently drafting these up, and that draft should be available in a week or two. If you have any questions, there's some email pointers at the end of the presentation. You're welcome to call me or contact me, and I can point you to the document when it's present. Where are we in terms of testing? We've been testing this as it goes along. It's kind of a continuous process. We now have seven independent implementations of the protocol spec, right? So Nordinet I guess about a year and a half ago, started developing a package called OpenNSA. And this is just a code that implements these protocols. We were going to try and use Oscars, but we had some conflicts with priorities and such with the ESNet. And so we decided it was easier and faster to just do a greenfield implementation. That's what we did, and it's actually becoming quite popular. DRAC is something that SurfNet worked on. G lambda A and G lambda K, believe it or not, these are completely separate codes. They were, I think they're based on a certain model that the Japanese had explored. But interestingly enough, one of these is developed by KDDI Labs, which is a commercial provider in Japan. We have Audubon, which is getting their version going. That'll be what the bandwidth on demand uses in Gen 3 Plus. Dynamic KL, the KISTI guys in Korea. And I believe all of these are open source. So you're free to download them, explore them, look at the code, modify it, adopt it, you know, as you wish. We're also testing these in the GLIF. For those of you who don't know, the GLIF is the Global Lambda Integrated Facility. It's just a bunch of academic organizations got together to deal with intercontinental provisioning of wavelength services. It's been going about 10 years, but two and a half, 3 years ago, we started a pilot project called the Automated Goal Testbed. The goals are GLIF open light path exchanges. These are exchange points around the world that try to act as if they have no policy, right? So if you connect up to one of these exchange points, you can peer with anybody else at these exchange points. The operator does not impose any sort of transit policy. There's a long story there. I don't want to get off the topic of NSI, but this is an architectural issue that a lot of these networks are starting to realize is really important, certainly to the R&E community, to do global science. And it's starting to, and it's not unheard of in the commercial sector as well. But we have created a test bed that has about 14 of these exchange points around the world. There's other organizations that have provided capacity between these exchange points. People have provided work or other sort of software development to support this facility. And so right now, all of these points are running a version of NSI version 2. And now that it's standardized, they're all going back and hustling, trying to get to get the minor changes that we settled on at the end, right? So they're moving everything up to the official version of the Charlottesville suite. And that should be demonstrable in the next 30 to 60 days. But this test bed is available to users as well. It's not just for NSI testing. We use NSI to provision the circuits across this facility. But any application, science application that thinks that they have a globally distributed environment that they want to learn how to provision and adapt to is welcome to run this. I was the chair of this group for 2 years, but I've passed it off to Gerben van Mellenstein at SurfNet now. So we should be, if you want to use this, you're welcome to it. Now, here we go. So the participants, you can see a bunch of these are all the guys we know and love from the global community. CERN-Light, Czech-Light, Creo-Light, Nether-Light, Northern-Light. And these are many of the guys that helped us or moving to deploy some version of NSI in an open exchange and participate in this. I've recently spoken to the Genie community in the US as well, and they're going to try to start integrating this into some of the experimental work that the Genie program is doing. So Nordinet is planning to deploy an NSI-based bandwidth on-demand service that's compatible with Jant and Internet 2 and these other networks. We have a lot of details to work out yet, but it's basically going to be based on the Charlottesville suite, which is intended to be complete enough that we can run production services on it. We'll have access points, we're planning to have access points, STBs, in all of our core POPs, which includes some of those in the US. Maybe not all of them actually, but the exchange points. There'll be interfaces and tools that will be available for the operations and engineering function to actually manage, monitor these connections that transit Nordinet. And there'll be interfaces available for applications programs or for other downstream networks, SUNET, UNINET, or other networks outside that Nordinet peers with. We're planning at this point, this service will be an Ethernet framed pipe. We'll probably implement this over MPLS, right? Because MPLS is a really elegant switching technology. Much better than Ethernet, native Ethernet. Native Ethernet wasn't designed for these type of wide area services and has a number of problems. But the Ethernet over MPLS is fairly well understood. It's supported in most of the major core routers, all of them as far as I know. We'll be aggregating services from the Nordic region and presenting those to Jean or where possible to North American peers or other places that we peer with directly. It's still in the early stages. You should see an announcement sometime in the next few months where we have this lined out much better. A couple of last slides here. There's the SDN terms, software-defined networking. A lot of people were wondering how NSI and software-defined networking interoperate. We tend to view these as opposite sides of the same coin. At the end of the day, our networks still, SDN or not, our networks are still architecturally viewed as switching and forwarding elements with transport links between them. And so if you think about what SDN does, it's really about redefining our switching and forwarding processes. And NSI is really about building transparent pipes between these elements, these switching and forwarding nodes. So we think that these are kind of the yin and yang of our future networks. So there's a couple examples I'll cover. NSI interdomain transit service. In this case, you might have an open flow space in one network, another open flow space in another network. These might be islands like a campus or data centers. And they can use NSI as a protocol and as an architectural model to set up a transparent pipe in between them. Now these two SDN worlds are adjacent, logically adjacent, and they can do what they like. And we haven't said anything about what's in the middle. There's the other side of this coin is that maybe even in the middle there might be open flow environments or SDN environments in these transit networks. We can still use the NSI protocols across them because NSI is technology agnostic. We don't really care how these guys implement the transit space, right? So this is why I say NSI and SDN really do coexist together quite well. And then you have this final step where we go to virtualized network services, where we're not just building transport links, but we're actually constructing virtual networks, or in terms of some of the current work, slices, right? Where you have controllers managing elements, forwarding elements in this logical slice that may be distributed across the globe. And then other slices that may have similar kind of footprint, but they're still a separate logical slice. We can use NSI to provision those pipes between them, and we can use other processes such as OpenFlow or other types of provisioning systems to allocate the computational resources, the storage resources that those pipes then connect. And in fact, the Xeon 3 Plus effort, Service Activity 2, is in fact building these kinds of test beds as a service. And we will be using NSI for the inter-element provisioning in that service. So I think I got 2 more slides. So the futures, We will be going to a version 3, if you will, for NSI. The two key things I think we're going to be exploring in that is going to be multi-point services. We're getting a lot of push from the vendor community, I mean the provider carriers, in particular some of these in Japan, who want to use NSI to do point to multi-point services, in particular video distribution. And so we have to address that requirement. Performance verification. Since all of these are performance guaranteed services, we need a mechanism that allows us to verify that the performance that was requested was in fact delivered to the user. That has to be a test that the users can run or that the providers can run. And it has to deterministically be able to show us where a fault lies if it's not meeting the fault localization. So that version 3 will begin ramping up in June timeframe. The topology service will be a big part of that. That'll be the first time that topology service is really going from something kind of static to something that's much more dynamic. And that'll give us a big step forward as well. And this fall and into next year, we plan on introducing this into IETF. And we're building the support amongst the vendors and the carriers to do this. So I'm pretty optimistic about this. I won't dwell too much the reasons we're doing this as applications. Real-time teleimmersive services are big drivers. Operational scalability, the network research. At the end of the day, this is the issue about nodes and links. I just gave you that. And the main thing to remember here is that we have two things going for us in NSI. It's an open standard. Anybody can participate. You know, if you have an idea what this protocol should do, give me a call. I'll tell you when the NSI working group meets. Introduce yourself, do your homework, and then participate. Anybody can do that. And by letting everybody participate, we get consensus, right? We make sure that we don't just vote and the minority gets hosed. We try to build a consensus where everybody agrees. Right? And that means that we get buy-in. I hope that means we get broad-based global deployment, and by doing that, we get ubiquity, and we end up being able to use these services no matter where our applications run. It will be in our bids coming up soon, and if you want information, you can go to ogf.org or to glyph.is, and we will, there's information there, and you're always welcome to either send me an email, hit me on Jabber, call me, get me in the back alley and pound on me and say, that's a stupid idea. Thank you.
Thank you, Eric. I think we have time for a couple of questions from the audience.
Hans.
Yeah, thank you for a nice presentation.
Thank you.
Thank you for the nice presentation. Now we know what this is. Do you have any actual users who use it and hope that provides this service?
Yes. Our first application use is the VLBI guys. Paul Boven is developing applications that will use this to reach from, in particular, Onslaught. I think there's a telescope in Finland as well, where they would like to provision capacity from these facilities and other facilities around the world back to Jive in the Netherlands. And that was part of the Express project. There's LHC1, which is the high energy physics guys, or as some people call it,
Will
LHC.
they actually even faster than they have today?
Yeah.
You can provide more than 10 gigabit or 10 gigabit.
Well, if we can guarantee performance on the infrastructure that's available, right? So if somebody has 100 gig pipe, right, we can provision part of it, 10 gig, 30 gig, 40 gig, whatever it might be, to an application. What we actually, when we have these meetings with the high energy physics, the one we had in December, one of the experiments at CERN said, well, we don't really need huge capacity, but what we need is workflow, right? So we need to be able to guarantee that these data sets are going to be at that destination at a certain time. And so the best way to do that is to guarantee that we have the capacity or some sort of fixed capacity. Doesn't necessarily have to be 10 gig, but we have 1 million circuits a day, so 1 million transfers a day that we would like to do. And they're coordinating with all types of other processes that are happening at these computational facilities. So where a lot of the science ends up is that they want to use performance guaranteed services as part of a workflow strategy rather than like the BLBI guys are looking at it to actually move raw data from sensors to a facility elsewhere. So there's a number of ways to do this. I think one of the I think what we will see is that there's going to be a number of computer science folks that are going to want to do research. The SA2 part of the SHAP 3 Plus, I think, is going to be a big issue here because there's actually quite a user community in the U.S. that is looking at these virtual networks as the way that computer science will start exploring new, novel networking technologies.
One more question before the lunch.
I actually have 2 questions that I have to go offer. So the first question is, you're talking a lot about light paths, and can you elaborate what those light paths are actually allowing you to do? I mean, how are they actually light format independent? Can I actually use that wavelengths to put any kind of modulations?
Well, so what we're doing, Peter, is the protocols. They send these primitives from one network to the next.
I understand that. I'm just saying, today, you were saying light paths with one hand, and then you're suddenly saying it goes over Ethernet or MPLS. So now, how do I put my
when I say the light paths, I'm not implying particular photonic spectrum, right? Those kinds of lambdas or wavelength-based services, the reason people use light paths is because they wanted to get away from the term circuits, which were kind of old school.
So that going forward into the future, the smartest thing would be to use your control program, your control protocol to build optical paths, and then we can leverage the advances in technology. But my other question is, okay, so this, if you want to apply this to the real world, how about using this for Netflix? Like pay-per-view video to the home. Have you looked at the reservation schemas, the rate we need to process requests?
We know there's a scaling issue
Have you looked at
here.
how much spare capacity we need to set sitting idle for it to actually not be blocking?
No, there is actually an open call for JAWS 3 Plus that is out now. I think they just released it last week. And that is one of the issues that they want to explore. They're willing to put a couple €100,000 to exploring scalability, performance, verification of the protocol in larger networks. So we have not actually done any empirical studies of that. If you would like to, we would love to have you. Or if anybody would like to, right? I can point you towards funding sources to help.
I think we have to stop there. Thank you very much, Jerry.
Thank you.
Lunchen serveras snett ditåt strax bredvid där ni hämtade era namnlappar igår eller morse. Då syns vi igen på Anette. Tack. Ja, det ska vi. Frågan var, kan vi lämna dator och kläder och grejer här?